Our first speaker today is Martijn Walraven. He's the author of Meteor iOS, a DDP client that allows you to develop a native iOS app using a Meteor backend. Martijn has been programming since his mom bought him a second-hand Commodore VIC-20 when he was 9. He studied philosophy and cognitive science at Leiden University in the Netherlands. In recent years, he worked on a project to develop an open-source learning environment, and as part of that, he created the iOS DDP client that he'll be talking about tonight. Everyone, please welcome Martijn.
Thank you, Alice. It's great to be here. As Alice mentioned, a couple of months ago, I released this project, Meteor iOS. And I'd actually been working on it for a while. And the first question that might come to mind is, why did I do this? Like, why did I spend all this time developing this project? And to put it in like slightly more general terms, why should a native app developer be excited about Meteor? And that's the main question I'd like to talk about today. I had been working on a native iOS app, and I didn't want to write another REST API. I felt there was a lot of boilerplate, a lot of work that I'd done before. I also wanted like real-time data updates, and I looked into different solutions, including platforms like Firebase and Parse, but I didn't like the proprietary nature of the platforms. I wanted something that was more open, and that's how I found Meteor. And as a first answer, I think why a native app developer should be excited about Meteor is because of DDP, the distributed data protocol that underlies much of the full stack reactivity of Meteor. It's really what makes Meteor tick. And DDP, simply put, is an amazingly elegant protocol. As Meteor developers, you often take for granted what DDP gives you. And you might even have trouble explaining to people what's so great about DDP. They might say to you, isn't it just WebSockets? And in a certain sense, they're right. It is just WebSockets in the same way REST is just HTTP. But it's WebSockets plus a really well thought out system architecture. And that's what makes DDP so great. So one way of describing DDP is as sort of REST for WebSockets. And if you think about replacing HTTP by WebSockets, what it gives you is a communication channel that's not limited to request response. You can send messages back and forth. The server can initiate communication, can initiate message sending. And it's also stateful, which is important because it means the server can actually keep state on behalf of the client. And that's something that's very important in DDP. I'd like to start out by giving a quick demo, just to give some context, just to show you what the project is capable of. And this is the to-dos example app that many of you will be familiar with. Hopefully connected. Let's see if I can add a new principle here. Hope it works. Let's see. That always happens, of course. Well, it's there now. It's not as awesome as I would have liked. Let's see. Another attempt. Let's add another language. Let's put Dutch in here. And now it works. We can also, of course, like check off tasks. Works on both sides. For those of you who know about this, note the latency compensation on the client, like it's immediate. We can also start a new list. Let's call this one favorite philosophers. It's visible here, of course. I'll keep it at this. Let's see if I add a philosopher here. You can see the incomplete count changing. I'll add one more just to show you it's working. And there's one more thing I'd like to try. If I log in here, I get the option of making this a private list. As you can see, it's disappearing from the native iOS client. I'll talk some about how this works later. And if I log in here, you can see the private list showing up. So that was the demo. Going on, like one of the principles that is really central to DDP is sort of replacing requesting, the kind of operation you're used to with REST, with subscribing. And what subscribing allows you to do is basically tell the server what subset of the database you're interested in. Of course, this is familiar to most of you who've worked with Meteor before, but for iOS developers, I think this is a really neat way of looking at connecting data. And the server, as I mentioned, keeps stateful. And it acts as a single source of truth. This is important, that is responsible for managing the contents of a local cache that is kept on the client. As we've seen in the demo, it actually means that subscriptions are reactive. If you subscribe to a subscription called private lists, the server will send you all lists owned by the current user. If you're not logged in, you won't get to see any of those lists. If you log in as a different user, the server is responsible for sending you a different subset of the data. And all this is responsibility that you can sort of leave to the server. You don't have to do this yourself within your client. You don't have to, all you have to do is log in the user. You don't have to keep track of what requests depend on the current user, redo them, invalidate caches, all that is done for you. The local cache also supports live updating queries. And in Meteor iOS, this is done through core data. For those of you not familiar with iOS development, core data is an Apple-provided framework. And a common misunderstanding is that core data is like a database. Core data is not fundamentally about persistence. That's important to realize. Core data is perhaps best described as a model layer, sort of a generalized model layer, and it offers object graph management. So it keeps track of changes, it allows you to traverse relationships, and it also provides detailed change notifications that you can use to update the UI. And in iOS, you get some system-provided classes that help you hook up core data to table views, for instance, like we saw before during the demo, even providing things like animations for you. If you look at what's actually required to hook up an iOS app to a Meteor server, like one of the things you need to do is define your object model. This is something you would do within Xcode, the Apple-provided development environment. Basically, you define your objects, your entities, their attributes, their relationships, the fact that a user can have private lists, that a list has an owner, that a list has to-dos. This is something you would edit within the Xcode interface. And then all you need to do is write a few lines of code. I don't want to go into a lot of detail, but to give you like a small impression of what this framework could do for you, you can see the load content method there with the add subscriptions. This is similar to sort of the wait for option in Iron Router. So it displays a loading indicator. It waits until both subscriptions are ready before it executes the contented load method. And then with this bit of code, we actually hook up our core data with the table view. So by only writing a few lines of code, you get the kind of reactive updates you're used to from the regular Meteor. Updates directly from the database to the UI, like real full stack reactivity. There's one part missing though. What about performing updates? So as many of you know, the way to update data in Meteor is by calling methods on the server. And methods may return a result, but can also modify the database. And if they do so, changes to subscribed data are sent to the client. If you use core data, you use regular object manipulation methods. So for instance, here we are creating a new to-do. We're giving it a text. We're relating it to a list. The list is also an object. We're updating the incomplete count of the list. And then we're saving. And Meteor iOS will take care of sort of translating these changes into operations that can be performed on the server to sort of boilerplate CRUD methods that are called. It inserts a new to-do, which includes a list ID reference, and it updates the incomplete count of the list. So one missing part, latency compensation. Why do we need latency compensation? Well, basically because there's latency. And especially on mobile devices, latency can be substantial, like up to maybe even a couple of hundred milliseconds, at least noticeable. Like most apps need some kind of latency compensation, or they wouldn't really be usable, or they would provide a really bad user experience. But performing latency compensation manually is usually a mess. It really messes with your application architecture. Like what you'd often do is update the UI at the same point where you're contacting the server. And then you have multiple places where you're updating your UI from, which is messy. But you also get inconsistent state. You want a very clear path from your state to your UI. And Meteor's solution is really neat. And I kind of stole this from Matt, who recently gave a talk about this. You can think about it in terms of truth versus speculation. Like you have your single source of truth that's managed by the server. That's your server truth. And then the client has the ability to speculate about what will happen or what is likely to happen. It sort of forks the local cache to provide the option to speculate. How does it do that? Well, by simulating method calls on the client, by sort of executing code that updates the database the same way your server code would do. And as Meteor developers, you're used to an isomorphic API. You use the same language, JavaScript, on the client and the server. Your database API is the same. And that means you can often share an implementation between client and server. You can't do that with Meteor iOS. In many cases, however, you don't have to define your method stubs. Like if you're only using sort of boilerplate CRUD, if you're only inserting or updating or doing simple stuff, those stubs are provided for you. But if you have custom methods, you have to define your stubs in Objective-C or Swift, but you can use core data within them. So they're actually pretty neat. They usually end up as a rather clear way of expressing what the purpose of the method is. So one of the most difficult parts of writing this, this client was actually the latency compensation, getting that right. Because knowing when you can throw away your speculation and sort of go back to the server truth is difficult. Because you tend to pile speculation on top of speculation if you're running method stubs. Like method stubs can be concurrent. You can have multiple, they can be recursive. So basically, the easiest way would be to just wait till all ongoing methods are completed, till all data changes have been received. But that would mean that long-running methods could actually block data updates from ever getting to the client. So you'd stay in your speculation mode. And this was something Meteor, in its early days, also had this problem. But it found solutions to it, and I was able to use those solutions and implement them in this client. So it's actually a pretty neat way of doing latency compensation. And I learned a lot about the way Meteor has been implemented and about, well, just neat solutions. I will only mention random ID generation, another great, actually pretty simple solution to a difficult problem. So sort of the takeaway message of this talk is if you're an iOS developer, Meteor really is an amazing backend for your app, and it will save you tons of time. There's actually, if you look at the amount of like REST code in most iOS apps, it's a substantial part of your app. And if you can take that away and get things like latency compensation for free, it's just a much better development experience. If you're a Meteor web developer and you choose to develop a native iOS app, it's now really easy to have that app participate in Meteor's full stack reactivity. It's just a great way to have a native app really give the same experience as your web app. All right, so that was what I wanted to say. This is the GitHub URL. Please take a look at the project. You can run the examples, the to-dos example I showed, experiment with it, and if you have any questions or any comments, let me know. All right. Do we have time for questions?
Yes, we have a few minutes for questions. Does anyone have a question for Martin about this project?
What can you speak about, Martin, about going forward to the watch as a container, as the Apple Watch in a container from iOS and right through there? Have you done that part yet?
I haven't looked into it, but oh, I'm sorry. I'm sorry, what would you? Oh. I think the question, if I understood correctly, was have you looked into Apple Watch and using like an app, an iOS app on a phone using this client to communicate with the watch? Was that what you meant?
Yeah, or just have potentially your full build going right through to the watch as well.
Yeah, I don't know enough about watch development, but I guess just having a normal iPhone app that used this library, it would be pretty easy to hook that up to an Apple Watch. That's like, but it wouldn't really have anything to do with the project specifically, I think. That's.
Other questions?
Yeah. How do you feel about the common UI pattern of pull refresh versus just completely reactive type of interface?
It's mostly a user experience decision. So in some cases, it makes sense to like reflect your updates immediately. In other cases, like take the Facebook news feed, you don't want to, like while you're reading it, you don't want it to change too much. So it's up to, yeah. it's not a technical decision, it's a user experience decision, I think. Any other questions? No? Well, thank you.
All right, thank you so much.